Question 3.7. A cruise ship moves southward in still water at a speed of 20 km per hour, while a passenger on the deck of the ship walks towards the east at a speed of 5 km per hour. The passenger's velocity with respect to Earth is. So, here in this question, I have a ship that moves southward with speed 20 km per hour. We can show the ship with the help of this velocity vector Vs. Then we have the passenger on the deck of the ship that is moving towards east with a speed of 5 km per hour. I will show the velocity vector of passenger towards east as Vp. We need to find the passenger's velocity with respect to Earth. So graphically, the passenger's velocity with respect to Earth will be the resultant of these two vectors, which you will start to draw from the tail of the first vector to the head of the second. So this is the passenger's velocity with respect to Earth. I will write this as VPE. I need to find the magnitude of this velocity. By looking at this vector diagram, we understand that the two velocity vectors, velocity of ship and velocity of passenger, are perpendicular to each other. And we can find the resultant of two perpendicular vectors by using Pythagorean theorem. So I find velocity of passenger with respect to Earth equals square root velocity of ship squared plus velocity of passenger on the ship squared. That is equal to velocity of ship is 20 km per hour. That of the passenger is 5. And when you solve this, you get the velocity of passenger with respect to Earth to be equal to 20.6 km per hour. Next, we will find the direction of this velocity with respect to the velocity of the ship. So I need to find this angle theta here. To find theta, you can use any one of the trigonometric ratios. I'm going to use tan theta. We know tan theta is opposite side over the adjacent side. And here my opposite side is the velocity vector Vp and adjacent side is Vs. So you can get theta equals tan inverse of Vp over Vs, which is equal to tan inverse of Vp is 5, Vs is 20. That gives you the angle theta as 14.036 degree, or you can round this off to 14.04 degree. And if you show direction here, this is east, this is west, then you have north and south at the bottom. If you were to show direction of this velocity vector with respect to velocity of the cruise ship, velocity of passenger with respect to Earth is 14.04 degree east of south. So we'll write this as 14.04 degree east of south. East of south because you are moving 14.04 degree towards the east from south. So this is my direction.